Okay, let's look at question number 1. We've got a couple of data tables to look at. One is of white rocks and one is of black rocks. So we have 3 samples of each, and they give us the mass and the volume. So it's pretty straightforward as far as us calculating the density. So you have to remember what our density equation is. Density is mass divided by volume. So we have mass divided by volume. So we have 42.6 divided by 10.1. Okay. So if you put that in your calculator, you should get 4.23. Then we have 29.5 divided by 7. So this should give you 4.21. And make sure when you're listening to me that you actually do this, or if you've already done it, then you don't have to do it. But if you haven't done this yet, you need to practice entering it into the calculator. All right, the next one, third sample is 84.9 divided by 20.2. So you should get 4.20. So pretty close to all. Then we're going to come over here and do the black rocks. It's the same thing. Mass, 13.8 divided by the volume, 4.45, and I get 3.10. 58.4 divided by 18.8, and I get 3.10. And then 60.1 divided by 19.4, and I get 3.09. Okay, so I did all my calculations. Now I need to look at the question. Which type of rock, white or black, has the greater density? Well, now that we've done the calculations, it's pretty straightforward. It would be the white rocks. So we're going to say white. All right, and then if you look at the next part of this question, circle the set of particle diagrams that are labeled correctly. So we see a bunch of black dots. Now pay attention, because here it puts the white rock first, and over here it puts the black rock first. So they've flipped it. Well, the white rocks are more dense, so they're going to have more black dots. So that is going to be this one there. Okay, another density problem. What is the density of a piece of metal whose mass is 210 grams and volume is 37 cubic centimeters? So we want to write our density equation down. Density is mass divided by volume, which is going to be 210 grams divided by 37 cubic centimeters. Okay, so this is pretty straightforward. We put it into our calculator, and let's see, I don't have my calculator. Okay, you should get, I think it's 5.6 something. We can only keep 2 significant figures, so it's going to be 5.7 grams per cubic centimeter. So you want to make sure you keep your units, and that is the answer for number 2. Okay, question 3. A certain liquid has a density of 0.79 grams per milliliter. So density equals 0.79 grams per milliliter. Calculate the volume. So volume, we don't know, of 35 grams of the liquid. So mass equals 35 grams. How do I know that? Because of the units. All right, so what's the equation? So I'm going to make my little triangle here to help me figure that out. Density is mass divided by volume. So if I cover volume up, volume equals mass divided by density. So now we just plug in the numbers. 35 grams divided by 0.79 grams per milliliter. And at this point, I want to look at how many significant figures I can keep. And so there's 2 significant figures in my top number. There's 2 here and 2 there. So my answer can have 2. All right, so 35 divided by 0.79 and I get a 44.30 and so forth. I can only keep 2, so I'm just going to say 44 grams cancels out, and the unit is milliliters, which makes sense because it's volume. All right, number 4. Find the mass. So this time we're finding the mass of a 10-liter bottle, and I want to make this 10.0. I should have typed it in there like that, but as 10, I can only keep one significant figure, and I don't want to keep one. So volume, we're going to say 10.0 liters, and then the density is 15.3 kilograms per liter. All right, so in this situation, I have 3 significant figures here, and I have 3 there. So this means my answer can have 3 significant figures. All right, so let's figure out our equation. So get back my triangle. Density is mass divided by volume. And we are calculating mass, so I cover that up. So mass equals density times volume. So we plug our numbers in. I like to do parentheses if I'm multiplying. 15.3 kilograms per liter times 10.0 liters. Now my liters is going to cancel out, so I'm going to end up in kilograms, which is good because it's mass. So at this point, you have 15.3 times 10. You get 153. You really didn't even need to put that in the calculator. 153. But this is why I added that extra 0.0, because I really didn't want to change that number to something else, just to satisfy significant figures. Okay, so number 5, a bowling ball has a density of 6.5 kilograms per liter. So I want to write down what they tell me as I read the problem. I've always done it like that. Just helps me keep everything organized. 6.5 kilograms per liter. And it has a mass of 5 kilograms. And the question is asking for volume. So once again, I'm going to do my triangle. Density is mass divided by volume. I'm going to cover volume up. And this tells me that volume equals mass divided by density. So my mass is 5 kilograms divided by my density, which is 6.5 kilograms per liter. So watch what happens to our units. Kilograms cancels out, and we're left with liters. So we have 5 divided by 6.5. You just put that in your calculator. And we'll have to watch the significant figures, but we're going to kind of cheat on that. So the answer is 0.77 liters. Okay, once again, this number here, I should have made it 5.0 so we could keep 2 significant figures. But if we wanted to be true to significant figures, the answer would be 0.8 liters. But on the test, I made sure everything is exactly how I wanted it to turn out. All right, number 6. A 43-gram piece of gold. So actually, I want to organize this a little bit different. I'm going to be doing calculating for gold. Hang on, I'm in highlighter mode. I'm going to calculate for gold and silver. All right, so the mass of gold is 43 grams. And it has a volume of 2.9 cubic centimeters. Now silver has a mass of 75 grams and a volume of 6.7 cubic centimeters. So I need to use the density equation. Density is mass divided by volume. So for gold, it's 43 grams divided by 2.9 cubic centimeters. And that is going to equal out to 15 grams per cubic centimeters, because I can keep two significant figures. Silver, we've got 75 grams divided by 6.7 cubic centimeters, and that is going to equal to 11 grams per cubic centimeter. All right, so let's go back to the question. The question says, which metal has the greater density? So we look at this and we can see that gold has the greater density. All right, let's move on to the next question. So here we're using a graduated cylinder, kind of like what you used in the lab. So it says, what is the density of the fish whose mass is 5.75 grams? I know that's a comma there, but it's supposed to be a decimal. What is the density? Okay, so density, right, our equation is mass divided by volume. So I need to know what volume is. And that's how I have to come over here. So we're reading this, and it looks like it's at about 32 here. So 32 milliliters. And over here, it looks like it's about 38. So to calculate the volume, I have 38 milliliters minus 32 milliliters. So that is a total of 6 milliliters. So my density equals 5.75 grams divided by 6 milliliters. So you put that in the calculator, and I get 0.96 grams per milliliter. And that is my answer. So let me check the significant figures. Oh yeah, this only has one here. Well, and there's some rules about measurements and how we don't count significant figures with those. So basically, the number we would use would be this number, meaning I could have up to 3 significant figures, but this is fine. We'll go with 0.96. All right, and then here it says, convert the following numbers to scientific notation. Now, if you know how to use your calculator, you can just put this number in, put it in scientific mode, and it will tell you what it is. And that is the best way to do these things so we don't get them wrong. But let's say we don't know how to do that. The decimal is here. We're going to move it 1, 2, 3, 4, 5, 6, 7. So it should be 1.402 times 10 to the 7th. How do I know it's a positive number there? Because this is a large number. I can already see it's a large number. If it's a small number, it's going to be negative, like B. So B is a very small number. It's less than 1. So I know my exponent is going to be negative. So I'm going to have times 10 to the negative something. So what is that? I'm going to move the decimal 1, 2, 3, 4. So it's 3.002 times 10 to the negative 4th. But once again, you can put this into your calculator. Just type it in 0.0030020. And if it's in scientific mode, just hit enter. If not, put it in scientific mode. So to do that, you're going to hit the second key and then the key right next to it, which is DRG. And then up at the top, it will say flow and psi. And you want it to underline psi. And so use your arrows to move it, and then hit the equal key, and it will give this number just like this. So that's pretty cool. 5200, you got the decimal there, you're moving it over 1, 2, 3. So this is 5.2 times 10 to the 3rd. 1, 2, 3. All right, here, number 9, we're just counting significant figures. So we don't count these zeros because they are leading zeros. So we have 1, 2, 3, 4, 5. 5. This 0 is sandwiched in between two non-zero numbers. The 0 at the end is after a decimal and a non-zero number, so it is significant. So here we have two zeros that are sandwiched between this and then this ending 0. So we have 1, 2, 3, 4, 5. So this has 5. This ending 0 is not significant. Here we have 10 with a decimal 0, so there's 3 significant figures. We count this 0 because it's after a decimal. You treat the decimal kind of like a non-zero number. So that ends up with 3 significant figures. Okay, just continuing with the significant figures. We have 1, 2, 3, 4 here. And then here we have 1, 2, 3. These are trailing zeros. Here we've got all these leading zeros, not significant, so 1, 2, 3, 4. Okay, so the next one is just basically using your calculator, and your answers have to have the correct number of significant figures. So that's going to be the main thing, because these aren't hard problems. We just put them into a calculator. So at this point, we have to know how to count significant figures. So the first number, 1300, has 2 significant figures, and this one has 3. So our answer can only have 2. So when you put that in the calculator, let's see, we have 13, turn it on, 1300 times 125. We get 162500. Okay, I can only have 2. So this is the answer the calculator gives me, 162500. Well, that has 4 significant figures, so I can't have that. So at this point, we have to round. So we're going to say 16 and then just change everything else to zeros. So we rounded it, and that gives us 2 significant figures. So our next one can only have 1 significant figure, and this is where it gets really challenging. So we have 2150 times 10, and the answer is 21500. I can only have 1 significant figure, so I basically have to round this up, I'm gonna round it down, because 215, that would change it to 22. That's still, I just gotta put the 2 and the rest zeros. If this number would have been a 5, then I would have put 30,000, but it's not. All right, the next one, we got the same situation. Because of that number, my answer can only have 1 significant figure, and that is what makes it really challenging. So we have 4,000 divided by 12, and we have all 3s. So basically you have 3, 3, 3, and 0.333. So basically I have to round this to 1, so I'm going to say 300. All right, the next one, we have a scientific notation number. So you need to know how to enter that into your calculator. So I say 4.5. I hit the second key, then the EE key, which is actually x to the negative 1. And then I put the exponent of 9. And then I divide it by 10. And I get a really long number, so I'm going to put it in scientific mode, and it gives it to me in scientific notation. So I can only have 1 significant figure. In scientific notation, it's 4.5 times 10 to the 8th. I cannot have 2 significant figures, so even this I have to round to 5 times 10 to the 8th. All right, the next one, E, 1 significant figure again. I don't like these. 358 times 200. I get 7.16 times 10 to the 4th. That's in scientific notation. So I could say 7 times 10 to the 4th, or I could also say 70,000. Both the same number. both one significant figures. All right, F, I want to make sure my calculator is in scientific mode, and then I'm going to put 1.2 second EE, and then hit the negative button, and the negative button is going to look like this, not the subtraction key. And then put 5, and then I'm going to multiply it by 3 second exponent 12. And it's going to give me my answer in scientific notation, which is 3.6 times 10 to the 7th. So I look at how many significant figures can I keep. There's 2 here and 3 here. I can keep 2, so I'm good. That one I can leave. So for the next problems, I'm going to put my calculator back into the FLO mode because these don't have scientific notations. So I have 0.0022 divided by 0.0510, and I get a long number, so I can keep 1, 2, 1, 2, 3. I can keep 2 significant figures, so I get 0.043, and I'm going to stop there because I can only keep 2 significant figures. All right, next one is pretty straightforward, 0.045 times 0.2. All right, so in this one, I've got 2 significant figures here and 1, 2, 3, 4 there. So I can keep 2, which is good because it's 0.009 is what my calculator says. I have to add a 0 to make it 2 significant figures. And then I have 0.42 times 0.003. This one, I can only keep 1 significant figure. So I have 0.001. Now the number in the calculator was 0.00126, but I have to drop those 2. Then I have 3,200 divided by 2, 1 significant figure. 3,200 divided by 2 is actually 1,600. And this is one reason I hate to stick to these rules all the time. But the only way I can have 1 significant figure is to round it all the way up to 2,000. Which to me doesn't really represent what the answer is, but that is the rule. Okay, and so for now, this test is about significant figures, so we're going to follow the rules. And then later, I'll tell you what we're going to do for answers. Okay, so this is just entering this in your calculator, and we want to have the correct number of significant figures. So we have to pay attention to that. So we've got 2 here, 3 here, so my answer can have 2. So 6,500 divided by 135, and the answer is simply 48. So with this right here, I'm going to put my calculator back in scientific mode because I have these exponents. So you put it as 5.6 second EE key in the negative number, not subtraction, 4. Then you're going to multiply it by 3.68 second EE and put the number 6. Right, that's that right there. And then hit enter, and I get 2.06 times 10 to the 3rd. So how many digits can I keep? I've got 2 here, 3 here. I can only keep 2. So this is going to become 2.1 times 10 to the 3rd. All right, and the next one, once again, just put it in your calculator. I'm going to take mine back out of the scientific mode. And I have 0.0458. Hang on, it didn't take it. 0.0458 divided by 0.00190. And I get 24. So let's look here. 1, 2, 3 here, and 1, 2, 3, 4 here. So my answer has to have 3. I'm going to put it in here again. 0.0458 divided by 0.00190, and I get 24. So I want to put 0.0. And that will make it 3 significant figures. Okay, so the next one, D, we have 1.2 times 10 to the third times 4. So it goes 1.2 second exponent 3 and times 4, which is 4,800. I can only keep one significant figure. So 4,800 then becomes 5,000 because I can only keep one figure. All right, the next one, 7,800 divided by 45, 2 significant figures there and 2 there, so my answer can have 2. I like to at least have 2. Divided by 45, I get 173. So I need to change that to 170. All right, F. We have 9,820 divided by 1.3. I get 7,554. I've got 2 significant figures here, 3 there, so I can only keep 2. So I'm going to round it to 7,600. The next one, G. We have 25,120 multiplied by 45.8. I get a long number. This has 4 significant figures and this has 3, so I can keep 3. So my number is 1,150,0. This is my answer. I have 3 significant figures. The number from the calculator was 1,150,496. So I just basically changed the 496 to 3 zeros. All right, our next one, H, we have 4 significant figures here and 2 there, so my answer can only have 2. So 0.0452 divided by 0.003, I get 15, and that's good. I can keep both of them. All right, I've got 2 significant figures here, so I can only keep 2. So we have 12,000 times 185. So a huge number. So this is what the number is in my calculator, 22,200,000. So I want to keep 2 significant figures, so I'm just going to change that 2 to a 0. So it's 22,000,000. And that gives me 2 significant figures. Last one, we can have 2 significant figures in our answer. So we have 65,020 divided by 120. I have 542, but because I can only keep 2, I'm going to say 540. All right. The next one, we want to convert from scientific notation to standard. So here's what I want you to try to do. I want you to put your calculator into scientific mode. No, actually, keep it in the FLO mode. So we're going to do FLO. And I want you to enter this as it is 4.29. You're going to hit the second key. You're going to hit EE. And then you're going to hit that -1 in parentheses, 7. So put all that in your calculator. So it's 4.29, second exponent, the negative number is 7, and then hit enter. 4.29, second exponent, -7. Now we may have to put it back in scientific mode. No, that's not working. Okay, so the answer is, I was hoping my calculator would do it for me, but it's not. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 4, 0.029. So basically what I did is I take this and I move it over 7. 1, 2, 3, 4, 5, 6, and 7. You put your front 0, and then you're going to put zeros all in. And that's how you get this number. I was hoping the calculator would do it for me, but it did not. So anyway, let's try the next one. See if it will do it. So 6.8, second exponent 5. And I'm going to put it in the regular flow. And this time it did give me the answer. So 6, 8, and then 4 zeros. But basically you're moving this over 5. 1, 2, 3, 4, and 5. And then you add all the zeros. 1, 2, 3. So I put that one in the calculator and it gave me this number when I hit equal, if it's in the flow. And then the last one, 7.54. I'm a second exponent 9. I hit enter, and hopefully this fits in the calculator. So you have 7, 5, 4, and I have 1, 2, 3, 4, 5, 6, 7 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yep. So basically you're taking it and moving it. It's a large number because this is positive. So we're going to move it to the right. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then you add all your zeros in. But the calculator gave me this one. I typed it in like this using that second EE key method. And then when I pushed enter, it gave me this number. All right, number 13, the last thing. You need to know this relationship. 1 milliliter equals 1 gram equals 1 cubic centimeter. So what this means is if I could have 25 milliliters, then I'm going to have 25 grams, and then I'm going to have 25 cubic centimeters, because they're all a 1-to-1 ratio.